So exponential functions, which is what we've been doing. So our time is our exponent, and it is a variable, okay? Now we're talking about logarithmic functions. Logarithmic functions are simply the inverse of the exponential function. So think about addition and subtraction. Those are inverses of each other. If you were to do addition and subtraction of the same number, they just cancel each other out. 3 plus 5 minus 5 is just 3, because the plus 5 and the minus 5 inverses kind of cancel each other out. Logarithmic functions are the inverse of the exponential function. And so they have this definition here. If you have, and I like to start on this side because this is what you know, if you have some number to a variable and that equals something else, another way to write that is the logarithm of the base. The bases are the same, the base of the exponent and the base of the logarithm. X, you'll see he moved from here to here, equals y. So let's look at an example. If I know for a fact that 3 squared equals 9, and I do actually know that fact, right? Then I can also say log base 3 of 9 equals 2. While this is saying 3 squared equals 9, this is saying 3 to what power equals 9. So my answer is the power. Whereas here, my answer was what happens when you take it to the power. In a logarithm, the answer is the power. 3 to what power equals 9? That is 2. Okay? So you are solving for the exponent here when you do a logarithm. Let's look at some just rewriting. Evaluate the logarithm. You do not need a calculator to evaluate these. All right? So if you just write that equals x, right? Then this means 3 to what power equals 81. All right? So that's just 4. The next one, if I wrote this equals x, this means 5 to what power equals the square root of 5. I can rewrite square root of 5. What is square root of 5 as a power? It's 5 to the what? 1/2, right? Square root. Remember, this is your numerator, this is your denominator. All right, so this should be an x. So that means that these two will equal the same. That means 5 to the 1/2 equals square root of 5. All right?
Why does it do it so often?
All right, same thing here. 7 to what power equals 1 over 49? Well, 7 to what power equals 49? 7 to what power equals... So how do I get it in the denominator? What puts something in the denominator with an exponent? Right, so x equals -2. X equals -2. All right, so if you're going to a root, a radical, it's going to be a fractional exponent. If you're going to a denominator, it's going to be a negative exponent, okay? And then let's look at the last one here. This is x. 2 to what power equals 2? There we go. Any base of the same number will always equal 1. Any base of the same number will always equal 1.
That was the hard part.
You don't think
All right. Any base of 1 is always 0. Why is that true? Because anything to the 0 power equals 1. All right? Anything to the 0 power equals 1. So if you have log base anything of 1, it is 0 because anything to the 0 power equals 1.
0.
Any base of itself is 1 because anything to the first power equals itself. All right, so if I have a base of the same number, it's going to just be 1. Because these guys cancel out to 1, if I have a base with the same base to x, it's going to equal x. Why is this true? Well, because I have b to the x equals b to the x. All right, so it's going to equal. Bases cancel out logs. So logs cancel out bases, and you get just the exponent. Bases cancel out logs, and you get this guy. Okay, so they are inverses of each other, so they will cancel each other out. Let's look at these examples. All right, apply the properties of logarithms. For this one, I can do this 2 ways. I can write it 5 to the x equals 125, right? And I'm going to get what? 5 to what power equals 125? That's just going to be 3, all right? Over here, bases of the same type cancel each other out. So I could just do this. This answer is just 4.7. All right, bases cancel each other out if they are the same base. So like for this guy, I could say log of 5, and I could rewrite this one like that. These cancel each other out. My answer was 3. Bases cancel out bases. Bases cancel out bases, always. All right? These are easy. Common logarithms. When you hear the term common logarithms, they are specifically talking about a base 10. So on your calculators, let's look at your calculators.
It always goes to 10.
On your calculators, you see just a log. Just the word log. That is automatically base 10.
We can change it though.
So if you don't see a base on a log, you assume a 10. Just like if I don't see something in the root, what do I assume? Square root, a 2, right? If I do not see an exponent for my x, what do I assume? A 1, right? If I don't see a coefficient for this guy, what do I assume? A 1, right? And so if you do not see a number associated with the log, it is a base 10. And so the same rules apply here. Any base of 1 is 0, including base 10. So that means log of 10, you can put it in your calculators, is just going to be 1 because it's base. These cancel each other out because it's a base 10, so you have just the x. These cancel each other out because it's just a 10, so you have the x. So the rules apply for common logs as well. For this guy, this is a base 10. So if you put it into your calculator, you should get a -3. All right, you should get a -3. For the next one, this is a base 10, this is a base 10. They cancel each other out. So what do I get? I just get 5, right? This will not come out to an even one. 10 to some power does not evenly equal 26. So in your calculators, you can just use your log, and you should get approximately 1.42 when you round it. All right? Let's put this into your calculator. What do you get when you plug that into your calculator? Tell me.
It should work.
Last one is saying, okay, take 10, raise it to some power, and make it -5. Okay, well, I can make it a root, and I can put it in the denominator, but I can't change it into a negative number. So if I have a base of a negative number, it's always going to be that it's not going to work. Okay, it's not going to work. Your logarithm of your negative number is not going to work. ln, so you should see just the ln without. So on your calculator, you should see a natural log. It's just going to be ln, and a lot of times it'll be in script when you see it in a book. It'll just be a script ln. It means that your base of your logarithm is your natural number. All your same rules apply. So all your rules apply to this like it does to anything else. So then if you see your natural log butted up next to an e, those are going to cancel each other out. And you're just going to have put your decimal in your right place, but you're just going to have your exponent there. Once again, natural log is a number. So you cannot have the natural log of -5. All right? For this one, the base here is e. The base here is e. These will cancel each other out. You'll just have a 6. And if it does something like this, you're just going to plug it into your calculator and you're going to get
1.3.
an answer. Decay here. You're going to see that logarithmic does the same type of thing as what it did before. With a base of b or a base of e, you're still going to see growth and decay here. And it is a continuous function, so there are no breaks in this particular function.